Hi guys, this is lesson 8-4. The vocabulary section you should be able to fill out, but just as a refresher, I'll remind you that square numbers, perfect squares, are a number that happens after we multiply a number by itself. So for example, 25 is a perfect square because 5 times 5 is 25. Or 1/16 is a perfect square because 1/4 times 1/4 is 1/16. So I'm going to leave this left side for you guys to fill out. If you have questions on it, you can ask me during class. But what I want to talk to you about is this key concept right here. This is a shortcut for squaring binomials. So if we have a perfect square like this, instead of having to write x plus 8 times x plus 8, and then using the FOIL method we learned in a previous lesson, we're able to do this shortcut. So it's just saying we take the first term and square it, then 2 times the first term times the last term, and plus the last term squared. Okay, so it's first term squared plus 2 times both terms plus the last term squared. So then we simplify it and we get this. Now notice on this B one, it's a little bit trickier because the first term has a coefficient. So see the 2m squared, because there's no addition or subtraction inside here, we can distribute that. We get the 4m squared. And then see how they've got minus the 2m times the 3. So it's 2 times the first term times the last term. And they have a minus sign because of this. This one had a plus. Alright, so negative 2 times 3 is our negative 12m. And then they had a typo here. They're missing a 12. Maybe your sheet has it. Maybe it just disappeared when I printed it on here. But that's where this 9 is coming from. Alright, pause the video and go ahead and do the first got it. Alright, we're going to use this first formula because the problem has subtraction in it. So we take the first term and square it. And then we do 2 times the first and third term, or second term, sorry. So negative 2 times negative 7 times n, so negative 14n. And then negative 7 times negative 7 is plus or positive 49. On this one, we have a square outdoor patio that's surrounded by a brick walkway, and we want to find the area of the walkway. Alright, so that's just the red area. So we want to take the area of the whole, basically the whole shape that we see here. So x plus 6 times x plus 6, so we can do that and use our shortcut. And then we want to subtract the area of the patio. And we can see that that's x times x. So we're going to do minus x squared. I want to talk for a second about where this x plus 6 came from, though. They gave us a label on here, but sometimes we might have to figure that out ourselves. So where that's coming from is we have this distance here is x, and then this is 3, and this is 3. So it's x plus 3 plus 3, and that's where the x plus 6 is coming from. Alright? So we take the area of the whole shape minus the area of the patio, and that will give us the area of just that brick walkway that's done in the brick color where it's 3 feet around each side. Alright, so we're going to use our formula and say that this is x squared plus 12x plus 36. That's what the x plus 6 squared is. And then we're going to remember our minus x squared. Alright, so you might notice right away there are a couple of like terms that we can combine. So x squared minus x squared is 0, and we're left with 12x plus 36. Pause the video and go ahead and try the next got it. Alright, it's very difficult for me to write in these little spaces with my stylus, but the 4 should be going into each of the little walkway parts, and x plus 8 is going to be the length and width of the entire outdoor area. And the reason I got x plus 8 is because the inside is x, and then we had to add 4 and then 4 more. So that's x plus 8. So if I did x plus 8 squared, so x plus 8 is going inside here, minus the x squared of the patio itself, then we would simplify and we have x squared plus 16x because there's 2 of them, plus 64 because that's 8 squared, minus our x squared. This step here is just telling us to put our like terms next to each other, and then we'll go ahead and put our leftovers over here, and then we're just left with 16 plus 64, and since we want to say feet squared, we need to put the whole thing in parentheses, which I should have done with this over here. I'm sorry for forgetting to do that. Alright? The really nice thing about learning this formula is we can start doing problems like 39 squared in our head, because knowing the formula, we can just think of 39 as 40 minus 1. And we know that 40 squared is 1600, because 4 squared and 10 squared. And then we would just think of this part in our heads. Okay? We don't usually write down mental math, but that's 2 times the first term times the last term, and then plus 1 squared. Now what's happening in our head is we thought 1600 minus 80 plus 1. So 1600 minus 80 is 1520 plus 1 is 1521. Go ahead and give the got it a try. Alright, whichever method you chose as the easier one, you should have ended up with 7,225. Next we have the product of sums and differences. This is one of my particular favorites because instead of having, like when we had a plus b, oops, why isn't this working? There we go, times a plus b, we'd end up with a middle term. We had the a squared plus 2ab plus b squared. But when we have one that's positive and one that's negative, we don't have a middle term, which makes this a lot easier to think about. But please remember, we can only do this if we have, they're called conjugates of each other. So we have the same first number in both, the same second number in both, but one is positive and the other is negative. Alright, so if I have r plus 6 times r minus 6, then that just means I'm going to have r squared minus 6 squared. I think that what they did here is they were doing, they wanted me to do the long way with foiling. So ignore that step there, but just do r squared minus 6 squared, so we end up with r squared minus 36. Alright, so let's go ahead and look at this one here. We have the same beginning, the same ending, and then there's a plus and a minus between the two. Notice this x to the third already has a power, so we have to think about taking that to another power. We need to take x cubed and square it, and then subtract from it 8 squared. Alright, whenever we have an exponent to an exponent, we know that we multiply those, so we'll get x to the 6th, and then 8 squared is 64. So x squared minus 64. Go ahead and pause the video and try the got it. Alright, you should have chosen the last formula, and we just take the first term, square it, the last term, square it, and put a subtraction sign in between them. It will always be a subtraction sign, because when we multiply the last term on each, we have one positive and one negative, and when you multiply a positive by a negative, you have a negative. So we'll always have a subtraction sign there if we're multiplying conjugates like this. Thanks to this method, we can do problems like 64 times 56 in our heads, because what we could do is we can just think of them both. The tens number that comes in between both those numbers is 60. Right? So between 56 and 64, the 10 number is 60. So I can consider the first term, 64, as 60 plus 4, and the 56 I can consider 60 minus 4. right? When we're doing mental math, we don't have to write this down, but I want you to be able to see what I'm thinking. So the first term squared is 3,600. The second term squared is 16. So then all I have to do is think about what that is, and voila, I have multiplied those two big numbers in my head. Alright, go ahead and try the got it. This is how your got it should have looked. The 10 that came in between them was 50. So we did 50 plus 2 to get 52, 50 minus 2 to get 48, and then we just squared the first term, squared the second term, subtracted, and landed on the right answer. Go ahead and try the lesson check. Write down some specific questions for me so you don't forget them, and make sure to be ready to ask me those in class tomorrow. These will become a lot more comfortable after we get to practice them together. So if you don't fully understand it yet, that's okay. Just make sure that you know the questions that you have to ask me based on how well you do on this lesson check. All right, thanks.